Hello and welcome to the Daily Space for today, December 16th, 2019. My name is Dr. Pamela Gay, and I am here to put science in your brain. We are happy to be back after a week of failing to see rocket launches. For those of you not following along on our Twitter and podcast feeds, last week our intention was to go to Florida and see possibly as many as 3 different rocket launches. But that didn't happen. It turned out all those dates, well, they got moved. So our attempt to bring you live rockety experiences right here on twitch.tv turned into us going to Disney World because we could. Now, for those of you wondering how a nonprofit like us affords to do something like this, we all paid for it personally. And this 1-week vacation was brought to you by my frequent traveler points, Annie's veteran discounts, and Susie's hybrid van. So we had a great adventure, we are recharged, and we are here to fill you up with science. Now, being the Monday that it was, things got off to a rough start. We are also having what we call a blizzard here in St. Louis, and the rest of the nation might call snow. So it's definitely a Monday, but it's a Monday that is filled with science, and it's pretty science. In astronomy, we often talk about how there's 2 things that you can ask people about if you want to completely wreck their day. The first is, how do magnetic fields affect that? The second is, how does dust affect that? And most of the time, most of us go through our careers calmly assuming that the effects of magnetic fields and dust are going to be negligible. But that's not always actually the case. And today's first 2 stories both involve people who took that extra step and went that extra mile and figured out what are the effects of magnetic fields and dust. Our first story actually looks at Aurora. And for those of you who have never seen Aurora, this is one of those reasons you should go extremely far north or extremely far south in March and September, or when there's good weather predicted. These regions produce these amazing shows of, well, gas getting excited in our upper atmosphere as particles from the solar wind fly along the Earth's magnetic field lines, interacting, exciting atoms, and leading to reds and greens and a variety of other colors being emitted. This is our own Earth's magnetic field interacting with the solar particles and, well, creating a light show. But our world isn't the only one to have magnetic fields. It's just the only one to have these colors of magnetic fields. We say magnetic fields on Jupiter, even in high energy X-rays when we look at that world. And it turns out Mars, which doesn't have a built-in magnetic field, still gets in on the Aurora show. In this case, what's happening is ionized particles from the sun. Here we're looking at hydrogen atoms that have had their electrons stripped off. So really they're protons flying through space, interact with Mars' atmosphere, and moving charge generates magnetic fields. So magnetic fields are generated in the outer atmosphere of Mars by these ionized particles. Now, when these ionized particles interact with the sphere of hydrogen gas that surrounds Mars, it can steal electrons from that hydrogen gas, leaving new protons behind, transferring energy, releasing ultraviolet light in the process, creating what we call a proton aurora. Now, those atoms that have been disturbed in the atmosphere, they're left vulnerable to effects that will send them flying away at, well, escape velocities, systematically removing these particles from Mars' atmosphere, giving it a thinner and thinner atmosphere over time. Now, you might be wondering, where is the dust in this story? Well, that dust, as we talked about a couple of weeks ago, it's down on the surface just waiting for a storm to send it into the atmosphere where we can end up with dust towers. And these dust towers are capable of funneling the moisture trapped in the soil up into the Mars atmosphere, where sunlight breaks those water molecules down, turning them into their constituent hydrogen and oxygen atoms. And it's that hydrogen that, well, is in jeopardy of getting literally blown away by the solar wind. So dust, magnetic fields, it all works together to systematically strip poor Mars of what little moisture it still has in its atmosphere. Now, all of this research comes to us from the MAVEN spacecraft. This particular spacecraft is tasked with trying to figure out how it is that Mars lost its, well, thick atmosphere and once flowing oceans. And this is one more step in that discovery process. And over time, well, we're learning all the reasons why we really shouldn't terraform Mars if we want what we do to stay put. Domes, people, we want to live in domes. The solar wind does not blast atmosphere out of domes. Okay, so moving on to something entirely different. We have a new study of Messier 77. This is a nearby spiral galaxy. And this weird image that looks like someone had way too much fun with Photoshop, this was produced by the Sophia Airborne Observatory as part of new work that looked at how magnetic fields are aligned in galaxies. And what they found is these magnetic fields are aligned along the spiral arms. And here's what we think is happening. The spiral structure in galaxies appears to be shaped by what are called spiral density waves. Now, if all the material in a galaxy were nice and evenly distributed as a function of radius, you'd have things orbiting, and their orbit would be determined by how much mass was internal to their orbit and, well, by how elliptical or circular, what the ellipticity is of that orbit. Now, the reality is, material in galaxies is lumpy, and as stars, clouds of gas, other material goes along on its orbit, if there is an overdensity, a dense area of stuff in front of it, it will get pulled into that. And then as it tries to orbit out, it will get slowed down. This causes material to linger in these higher density regions while getting pulled out of the lower density spaces between the arms. Over time, this builds up to these beautiful spiral arms and flocculent spiral structures that we see today. Now, that allows the dust and gas to get compressed, to get shocked. It generates star formation. And the stars that are forming in the arms may not live as long as their matter is in the arms, leaving the arms to be the richest area of star formation. Now, permeating all of this is magnetic fields, and dust grains embedded in the magnetic fields will align perpendicular to the magnetic field at a right angle. And this dust is radiating light in far infrared wavelengths, wavelengths of light that the Sophia Airborne Observatory can see. And by studying polarized light, light that allows astronomers to tell how the light waves are aligned in space using polarimetry on that Sophia Airborne Observatory, they were able to map out these magnetic fields, creating this crazy, awesome data visualization that I think is my favorite data visualization of the year. So dust, magnetic fields, it all aligns beautifully along the arms as the material gets compressed in its orbit around the galaxy. Now, our third story of the day is not one that brings us dust or magnetic fields, although these things could always play a role, we just aren't there yet. For now, this is a, hey, cool image produced cool science kind of result. And this is an image of the southern polar region of Jupiter taken by the Juno spacecraft. Now, as recently as February 2017, images of the southern region showed 5 cyclones orbiting a central polar vortex. But this November, the Juno spacecraft spotted something different. It spotted 6 storms instead of 5. And that new small storm, which is about the size of Texas or France, that new small storm Well, it bumped everything into a new alignment. Before, the polar vortices and the cyclones were aligned like a pentagon with a storm in its center. Now it's a hexagon. And so it turns out planets, well, they like normal polygons. And we don't entirely know how this happens. Previously, we hadn't even known if 5 was the number of vortices forever and always. Now we know that number at least can change. And we don't know how this will change over time. But it's a cool new discovery. And when looked at in color, we can see that the polar vortices on Jupiter are truly one of the most spectacular features in our solar system. It's a feature that, well, it turns out art struggles to recreate. Solar systems and science are sometimes more magnificent than what the human mind and hand can do on its own. So that rounds out our news for today. This has been The Daily Space, and I will now stick around and answer your questions. When you type them in, please use that purple circle that has a purple star in its center to make it easier for me to find your questions. And while you type them in, I'm going to remind you that this is a production of the Planetary Science Institute, a 501c3 institute dedicated to exploring our solar system and beyond. We are produced by Susie Murph. And we're in the middle of a massive year-end fundraiser. And we're not just going to beg for money during these half-hour podcasts each week. We're actually going to produce 40 straight hours of content this weekend, starting at 9 a.m. Eastern, Saturday, December 21st, and ending at 1 a.m. Eastern. Well, at that point, it's Monday. Local time, it's 8 a.m. Saturday to midnight Sunday. We are going to be bringing you 40 hours of content as we try and raise the money we need to keep our programs going for another year. We are currently in a position where we have a variety of federal grants pending. We have a grant that should have already transferred but hasn't, and we're now waiting for a federal budget. And we could use your help making it into the new year. Now, this is a month-long goal, and last year we hit our goal, admittedly, in the second week of January. We're hoping that we can do it during the month of December this year, but we understand there is currently a federal shutdown looming. So here's hoping we get a budget. So I see in the chat the question, is the 40K for the podcast? The 40K is for the podcast, the live streams, the website maintenance, and general everyday development of things around here. It takes us about 2 hours per episode to put out all of this content for the creator. So me, it's about 2 hours of effort. And then it's another 10 hours a week for Susie to maintain everything in the background. Then you have things like medical insurance. Well, we don't actually get medical insurance yet because we don't have enough hours. But there's things like income tax that have to go in on top of that. It adds up quickly. So just our media content, if we paid ourselves for all the hours we put in, we need to get that 40,000. But we'll see what happens. So Veronica is asking, are they talking about a shutdown again? This is a really weird year. So we should have had a federal budget back in October. One was not passed. We are currently in what's called a continuing resolution. That continuing resolution runs out of funding on December 20th. And the way a continuing resolution works is it says we'll continue funding existing programs at the rates they were at, with some wiggle room that occasionally gets specially written in, while the government works on writing a long-term budget. Now, we also have impeachment proceedings going on here in the United States. And in order for a federal budget to be passed, it has to get voted on in the House. It's supposed to go up for a vote on Wednesday. It has to get voted on by the Senate. It's unclear when it will get voted on in the Senate. And it has to be signed off on by the president, who always has the ability to say, I will not sign off on this until you don't convict me of an impeachment or whatever else he might decide to do. So in this confusing time, it's impossible to know what might happen. So we're all trying to not hold our breath, but we're actually all holding our breath as we watch to see what happens. Fun times. But science, let's talk about science, people. I am now going to scroll up to the top and work my way through the topics. So I started today's conversation with Aurora, and let's see what questions we have. So there is going to be a launch of Starliner later today, U.S. time, just into tomorrow in Europe. Not Starliner, of a SpaceX rather. Starliner is going to be early in the morning on the 20th. I will try and bring that to you. We will work to bring you tonight's launch as we can. Again, I'm having a blizzard. Good times. Hanny's Warverb asks, fully rested? Yes, I am. And I have a Velcro dog. For those of you who were here for the pre-show, Malachi is not letting me out of his sights. I'm looking to see if I can switch to a camera with him right now. Is he on that camera? Yes, just barely. Let me see what I can do to switch cameras. He's just kind of off the edge. So that's Malachi. He has become a Velcro dog who will not let me out of his sight because he is clearly deeply disturbed that I left. And he was willing to brave the big scary stairs to the basement to follow me. Eddie is outside playing in the snow. He was not interested in doing anything other than playing in the snow today. Thank you. Malachi has no clue what that means. Do you want to come here, boy? Come here. It's okay. I have a treat. Come here. Come here. Come on. I have a treat. Okay, he's going to take it over the edge of my desk. Come on. It's okay. I'm just going to toss it to him. So for those of you who don't know, Malachi is a dog I took in a few months ago who had been terribly abused. So he's quite cautious. So sometimes I just have to toss things to him because he thinks that you're giving him treats so that you can catch him. Come here, baby boy. Malachi, come here. I know, one went away. Come here. You can do it. Come closer. There. He let me hand it to him. Okay, we're making progress, people. We're making progress. He'll learn by the end of the hangout-a-thon, I am sure. Looking for questions. I like the way Bad Panda Bear puts it. We would call snow the end times in San Diego. Yes, you probably would. Hi, baby. I see you. He's like right past the edge of my desk. Come here. I will give you one if you will come get it. It's okay. Okay, I'm just going to sit here awkwardly holding a dog treat towards my dog. Looking for more questions. A wormy galaxy. Not a lot of questions today, but I'll bring the wormy galaxy back up because it's a really cool picture. It does look like a Van Gogh Paranor. So Paranor says, I believe soap bubbles do the same thing as the six storms. I'll need to look that up. I have no idea. That's cool if they do. Thank you, Trekker Kev. Long time no see. Come here. I will give this to you. Fine, I will toss it to you. Okay, I just bounced it off his foot. Veronica asks, what is the weather forecast for Jupiter? Cold with a chance of cyclone. And yes, Atke, the goal does say 40,000. But it's 40,000 to run a whole lot of different programs. Check out our website, hangoutathon.org, and it will tell you a lot more information. I will be putting a schedule of guests up later today. Yeah, poor binary blaze. The rocket shows are the hardest. And yes, they sometimes take her 8 hours. So Henny's Vorverb asks, how far do the magnetic fields extend from the galaxy? We don't actually know the fullest extent, simply because we can't measure them out as far as they probably go. So they probably don't extend all the way to the edge of the dark matter halo, but they do extend all the way through the luminous material that we're able to see. And I keep getting distracted by a window over there that is showing like massive amounts of like New England nor'easter levels of snow falling out of the sky. Michael asks, why do dust grains align perpendicular to the magnetic field? How do you tell? Dust grains are presumably irregular. So it turns out that the kinds of dust grains that we're talking about are complex molecules, and they will end up with, because there's a magnetic field, the charge going to opposite ends of the molecule. And they typically aren't totally irregular in shape, so they do have a dynamic to them. Complex molecules are often flatter than they are round. And all of these effects together end up with a molecule perpendicular to the magnetic field. That's a really good question. I don't have enough hand gestures to adequately explain. Thank you, Broken Symmetry, for all of the bits for Malachi. He is a wiggle butt. He's still learning to wiggle his butt, though. It's really sad. He's still learning how to be happy. Thank you, Keeper of Maps, for the additional bits. Stella, because she's so darn skinny, doesn't like to be outside for long periods of time, but she also needs to race incessantly. Last I saw, she had a mostly frozen apple that had fallen out of the apple tree and was tossing it into the air, watching it crash down and splash snow everywhere. And she was just having a grand old time. But then she'll run in for a little while and ask me to dry her off, usually by putting her wet paws on me. And she'll lie down next to the radiator until she's warm, and then she's back out and doing it again. Just like a typical toddler, I guess. Let's see what else is in here. Austin had the hottest December 15th ever. Dang, that is insanely hot. So Hanny's Vorverb asks, is it hot over the cyclones at the poles of Jupiter? That sounds like a lot of friction. I know that there's a temperature gradient in the storms. I don't remember which direction the gradient is. I'm sorry. I will see if I can find you that answer. So Michael asks, does that mean that the astronomical definition of dust is similar to the definition of metal? It's not that bad. It's basically dust is anything that's more than one atom. We're lame that way. So it's slightly better. Often dust is complex molecules that form in the spaces between stars. We've found crazy things like buckyballs, chlorofluorocarbons. Space is filled with fragile, large molecules. Okay. Yes, a doggy door is kind of required for my dogs. It is true. And now you are discussing Bennu landing sites. So one of the things that is on my list of things to do today is to finish putting together the lists of who observed what of the 4 potential landing sites. I will be notifying those humans today, and we are working on a release for later this week. So I think I'm going to go make some lunch, finish the audio editing, and then work on letting people know who contributed to what. Did you all figure out a way to contribute via Hangathon Google Pay? Oh, crud. No, I forgot I needed to do that broken symmetry. Susie, can you make a note of that? I need to figure that out. No, chlorofluorocarbons are not entirely artificial. You can actually get them naturally. Also polycyclic hydrocarbons, which is just a fun word to say. And alcohol. Yes, we do have alcohol in space. So I'm glad that you guys enjoyed the stream. I'm realizing I still haven't unpacked, so rolling credits is going to require a bit of leaning around. One moment while I figure out the credits. Okay, maybe. Will you reload the page, please? The screen that has Streamlabs on it is directly behind the camera. So, pardon me while I lean awkwardly. Okay. Leaning awkwardly the other way. So thank you all for being here. There will be a lot of ninja streams this week as we work on various projects and prep for the Hangout-a-thon. We will be here with the Daily Space and periodic launches as they happen throughout the week. So check back in and come get your fill of science. And wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye. Awkwardness looking. There it is.